I know there were a lot of it. Was about 35 minutes in total. So I know it was a lot. I also have the PDF copy of the notes. Those are going to stay up and stay posted. They're all up there. Totally valid. We are going to talk through a few more of the problems. But today we are going to finish everything out. I'm going to get through the rest of everything. And then the rest of this week is going to be review to get ready for our test on Friday. Okay? So we have 1, 2, 3, 4. 4 that we're going to do. Oops, that page is. Okay? So we're going to be working with our composition of functions. We ended with one kind of like this in the videos. This one's a little bit different, so I think we didn't do this one. Genuinely, I cannot remember. Did we do this one? Did this one in the video? Okay.
Because I copied it down.
All right, so that one's in the videos. We can talk through it real quick though. When we're working with these and we're working with the physical numbers being put in, work from the inside out. When we're doing our f of g of negative 2, remember that's whoa. Try it again. F of g of negative 2. So start from the inside. Find your g of negative 2 first. G of negative 2 means we're substituting negative 2 in place of the x. 2 times negative 2. What do we get? Negative 5. So what this is really having us do is f of negative 5, because we know g of negative 2 equals negative 5. So it's a substitution. We substitute the negative 2 in place of the x, then we're going to substitute this negative 5 in place of this piece here. And then when we substitute that into the f function, that's going to be our 2 times that negative 5 squared plus 3 times the negative 5, and then minus 4. So when we simplify that, what are we going to get? Is it negative 2? The negative 2 went in for the g of x, went in here. So the negative 2 goes inside g of x here. This is f of g of negative 2. So we do g of negative 2 first, and we get negative 5. Since g of negative 2 equals negative 5, we can put that in place of. So it's like substitutions. It's like a double substitution situation. What do we get when we simplify this now? We should get 31. Let's do the g of f of 3, just because we had some confusion on this one. I'm going to give us a little barrier here just so we can think about these separately. So then let's do our g of f of 3. That's what it says in the instructions up here, g of f of 3. So we're going to start by doing the inside bit, doing that f of 3. F of 3 is our 2, substituting in that 3, plus 3 times 3, minus 4. And what do we get there? Our f of 3 is going to be 23. Ooh, I got a what on this? So we're starting by taking the inside piece, our f of 3. Substituting 3 in place of x here. 2 times 3 squared, that'll be 9, so we've got 18. Plus 3 times 3, substituting that 3 in again. So plus another 9. We're up at 27. Minus 4, 23. And so now that we know that our f of 3 equals 23, I can come back over here to my g of, and instead of having f of 3, I know that equals 23. So we're going to substitute that in. So into the g function now, we're going to go with our 2 times that 23, and then minus 1. So what do we get? 45. So our g of f of 3 is 45. So this is our g of f of 3. So this is our answer here, and this one is our, just putting the titles in here, our f of g of negative 2. Okay, so composition we've worked with before. It's been a minute, and sometimes they're a little furry, a little hairy, likey, but we can do it. Questions on these ones? Okay, because what we're going to look at now is we're going to look at when we're composing functions, and we need to find the domain of the composed functions. So we're going to be doing like f of g of x. So we're just going to wind up with an equation here. So we're going to find our f of g of x, and we're going to find the domain of our new function. So our f of x is going to be our x squared minus 3. And our g of x is the square root of x plus 2. So the first thing I want to think, because we are talking about finding the domain eventually anyway, first thing I want to think about is, what is the domain of f of x here? All real numbers. This is a parabola. Our domain is everything from negative infinity to positive infinity. Everything. What about g of x? What is our domain over here? I've heard several whispers of ideas. I'm not entirely sure what you're saying. From negative 2 to infinity. X needs to be greater than negative 2 in order for this to not be imaginary. We do not want to have any negative numbers in my radical. So we need to be from negative 2 to infinity. So those are the domains of both of those original pieces. We found them. We're going to tuck them to the side and come back to them at the end. Because what we want to do is now we're going to compose these together. We're going to smush them together. So we're going to take our f of g of x. So f of g of x. That is what this says up here, f of g. I really like writing it like this. I feel like it makes things very much easier to keep track of. If you want to work from the fog and golf, more power to you. I feel like writing it and the parenthesis style makes it easier to keep track of things. Because what we're going to do is inside our f of x function, in place of the x, I'm going to put a big set of parentheses. So that would be my something, my x squared minus 3. But inside is where we're going to put our g of x. And g of x is our square root of x plus 2. So I'm taking my whole of g of x and putting it in place of the x in f of x. And then we're going to simplify. How can I simplify this? Because the square and the square root cancel each other out. I have squared a perfect square root. So this is the exact same thing as if I had just x plus 2 minus 3. So our f of g of x is going to equal what? X minus 1. So this is our composed function here. And if that's all we were asked to do, we'd stop right there. But it wasn't. So this is our composed function. If I just looked at that, x minus 1, what would be our domain? If I was just looking at this bit, it would be from negative infinity to positive infinity, because that's a line, like, that's a linear expression. But this wasn't just coming from the universe, and they gave us a line from nowhere. It was born from f of x and g of x. So it only lives in these two lanes. And it's only going to exist where both of them exist. So the domain on our composed function is going to be where this domain and that domain overlap.
Negative.
Does this one go all the way out to negative infinity?
Negative 2.
Negative 2 infinity. So it's where they overlap. They both have to be true. So this is going to have the domain of negative 2 to infinity. And we're going to practice another one of these because they're weird. Questions on this one? Hmm?
What about the negative? Oh, well, because, okay.
Okay. I was going to say, we're going to try another one. So again, we're going to do our f of g. Our f of x, we've got x over x minus 2. And g of x is our 3 over x. So it's very fractiony. And the first thing we're going to figure out is our domain. Where do we run into problems? And on these, a lot of times, it's going to be easier to state what's not in our domain than what is in our domain, and that's totally fine. At the end, we are going to write it in interval notation. But if you want to think about it, especially on these fractiony ones, as just everything except, totally valid. Because for our f of x, where do we have a problem? When our denominator equals 0, right? So when x has what value? 2. So it's anything in the existence of the universe except x cannot be 2. And that's totally okay to write it like this. That's not our final answer. We don't have to have it in interval notation right here. You can. Negative infinity to 2, parentheses, 2 to infinity. Totally valid. You can write it in interval notation. What about on G? What's our problem in the domain here? 0. X cannot be 0. So we know that. So then when we're looking to do our composition, when we're composing our function, f of g, so f of g of x. Okay, screen, can you stop twitching? Thank you. I'm going to take my g of x and substitute it in place of x. So in my f of x function, when we have our fraction, we have an x in our numerator, so that's going to be my 3 over x. And our denominator, we have our x minus 2, so that's my 3 over x minus 2. Does not cancel out. No, careful, 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 careful. Because I can't cancel out when there's subtraction.
You can't put it in this 3 over x minus 2. Well, what if you do this 3 over x minus 2? You go with 3 over x
I have genuinely no idea what you just said to me. Let's see what we can do to simplify this, because this is a hot mess. First things first, look in our denominator. Smush together. How can I smush those together? How can I rewrite 3 over x minus 2 as one single fraction? Make this be 2x over x. I'm multiplying it by 1. It's a weird looking 1, but it's a 1. So I could rewrite our denominator. There's a new color here. As, there we go. 3 minus 2x over x. That means the same thing. And our numerator is our 3 over x. So I can use, when we have two fractions being divided, what can I do to like switch that around? Keep, change, flip. So I'm going to keep the top fraction exactly how it is. I'm going to have my 3 over x. I'm going to change my division symbol to a multiplication symbol. And then I'm going to flip the bottom fraction. X over 3 minus 2x. Now what can we cancel out? The x's. The x's are going to cancel out. Not the whole 3 over x fraction. I'm going to change the view. Because our function here is going to be 3 over 3 minus 2x. It's okay to cancel when we have things that are being multiplied. Because this was x times 3 minus 2x. And this was 3 times x. So when we have things being multiplied, cancel away to your heart's content. As allowed.
Could you like solve it as like 3x over 3x minus 2x squared and then cancel the full 3x?
No, because if we multiplied it out, we'd have our 3x minus 2x squared. And if I had 3x, I couldn't cancel it out over here. So if we have adding and subtracting, we cannot cancel it out. Only when we have things being multiplied. So it has to be in factored form in order to be able to cancel stuff out. So this is our simplified function, and we can have it just like this. Yes, dear.
Why did you get rid of the x that's being divided?
Because we had one on the top and one on the bottom, we could cancel them out.
Yeah, but like, why'd you take that? You could say that from under the 3 minus 2x. Like, away.
Only if I could factor out both of them. It's like if I had 2 over, let's see, 7 times 2, 2 times 4 minus 2x. Making pieces up. I can cancel these 2's totally fine, but that does not cancel this 2 in here. Not a part of it. I only get to cancel one out because 2 divided by 2.
That I understand, but see how on that first part,
Mhm.
the X is, oh no, the part before that.
Over here?
The arrow over there, that X is under the,
Mhm.
there's 2X.
Yeah, if you cancel those 2 pieces out, you get exactly that. Cut your face. 3 over 3 minus 2x. So you can do it either way. If you see it right here, totally valid. Most of us have trouble seeing that one. So for most of us, we're going to do a keep, change, flip. But that's totally valid. You get the exact same thing.
Yeah, I got it.
Yeah. Cool, cool, cool. So if we look at just this guy, where do we have a problem in our domain? What can't x equal? I've heard it. It's quiet. I've heard it from a couple of places. 3 over 2. What else can't x equal?
Wait, can't you cancel out the 3?
Can't equal 0 either. We can't cancel out the 3 here. We would have to have it in factored form and it would cancel it out. So because of this piece here, x also cannot be 0. Because this causes us problems in our denominator again. So even from just this part of the function, we have 2 things our x can be. But again, remember, 'twas born from these. So also, x cannot be 0 from this guy. So we caught that already. But x can also not be 2 from this one. So it has to be in the same domains as where it came from. So x cannot be 0 from our g of x, but x cannot be 2 from our f of x. So that is still a part of this. So we have 3 places where x cannot be. So our domain of our f of g of x, because this is our composed function. So our domain is going to be from negative infinity up to 0. We've got to skip over 0. And then we'll get to 3 halves. Skipping over 3 halves. To get to 2, very small interval. Skipping over 2 to get all the way out to forever. Ugh, lots. Gross. But so it combines all of the pieces together. So anything that gets ruled out of our domain through our process, or anything ruled out of our domain from what we started with, all combine into our composed function. Okay. The last one, I promise, is not worse. The last one is, I think, much easier. It's one of my favorite ways to end. Because we're going to look at a table, 2 tables technically. We are going to do 5 more compositions. I am going to give you these tables. You don't have to speed write. I have them. If you want to speed write them, more power to you. But I have them. I will get the blue boxes up here in a second. I'm going to give you these. And we're going to do f of g of 6 as our first one. So let's do the table so you can figure out f of g of 6. And I will get out the blue boxes. Think about it. These will be our last ones. These are our last problems for this chapter. Yes.
Because they canceled those.
All right. So we've got our f of x our g of x on the bottom table. And the first thing we are asked to figure out is our f of g of 6. What is g of 6 going to be? Not 7. It is in fact 8. Think about g of 6. That means I'm replacing the x with 6. So when x is 6, g of x equals 8. So g of 6 equals 8. So I'm going to just mark that one. G of 6 equals 8. That's this one. I'm going to make that a little bit paler just in case we need that later. So this was our purple here. So if we know that g of 6 equals 8, so f of g of 6 is really saying, okay, what's f of 8? 5. When x is 8, f is 5. So f of g of 6 went to 5. So we started with an x of 6, it gave us a y of 8. That became my new x, which gave me a new 5. So f of g of 6 equals 5. We're going to try a few more of these just to practice them because they feel weird. So our next one has g of f of 6. So a little bit different. So g of, what is f of 6? 7. So g of 6, or sorry, f of 6 is 7. Yep, sorry. Mm-hmm.
Oh my God. You got it happening too.
Mm-hmm. 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 Yep. Okay, and so then our g of 7, when our x is 7 on g, that's this guy. So it actually went right back to 6. I promise on these tables, it's just that you overthinking it.
Wait.
Yep.
What do you look at?
So what's inside the parentheses is in your x. So f of 6, that's like if this was replaced with a 6. So we look at when x is 6. F of 6 is 7. F of 6, 7. So we're replacing the f of 6 with the 7. Then we're going to do g of 7. So now this is my x. When x is 7, g of x is 6. So we're going from 6, 7 to 7, 6.
6, 7.
I hear it a surprising amount in high school. Okay. So then they'll sometimes throw us weird ones. F of 6. It's okay. We're going to follow them through like a chain. So we're going to have our f of 6. So it still starts out the same way. And in fact, it's the exact same piece we had here. We already looked at f of 6. We saw f of 6. When x is 6, f of x is 7. So f of 6 is 7. So this becomes our f of 7. Because f of 6 equals 7.
Doesn't this one also equal 6?
And so here are f of 7. Now we're looking when x equals 7. So now we're here. Which actually puts us right back at 6. These things all wind up kind of tying together. So this was also our light green one. First time we used this one was our dark green. So this also equals 6. Yep, we can have in through itself. We did on that one f of 6. So we do our inside f of 6 first, which gave us 7. Then we do f of 7, which in this case gives us back a 6. It is important that we are careful and take our time because it's not just that they undo each other. This is not inverses. So I'm going to have another pair of colors because we're going to do our g of 6.
Will a problem like this be on the
Easily could be.
That means yes.
That does not necessarily mean yes. That means it could be. So here we have g of 6. So we can nest them inside each other. We've seen our g of 6 before. G of 6 we know to be 8. When x is 6, g of x is 8. So g of 6 is 8. So what this is really telling us is to do g of 8. It is not 6.
It's 5.
It is 5. Because g of 8 is this one over here. Actually, I want this to be darker. So g of 8 actually equals 5. One left to go. Very last question of the chapter. So we're doing our f of g of 9. Orange and yellow, I guess. So we're doing our f of g of 9. What is g of 9? 4. Because our g of 9 is 4. That's this one down here. What is f of 4?
9.
Not 9. We don't have one. We don't know. It's not in my list. In my list for f, I do not have an x of 4. It has not been written for us. It has not been defined.
So it's undefined.
It is undefined. F of 4 is undefined.
Couldn't you just like assume that it's like oh.
We cannot assume that it is anything related to the others because we don't have the information. We don't know if this is a parabola, if this is a line, it's actually a line. But we don't have the information. When we're given tables, we're not being asked to find out the equation of them. We are using the info we have. We do not know what this looks like, what it graphs as. We use the table we're given. Okay. So they're a little weird. They're a little awkward. It is what it is. Okay. Yes, dear.
Would this mean, like, if any question we're asking, like, if it asks any other question of, like, oh, even if it's, like, a 10, we just instantly say,
If it is a table and we are given not enough information for it, it's undefined. Because it has, we only work with the definitions we're given. And so I've been told when x is 5, f of x is 8. I cannot assume I cannot assume that this continues out this way or continues out that way. Maybe this was that they were taking surveys and I had 5 people that answered 8. Or no, I have 8 people that answered 5 and I had 7 people that answered number 6. I had 6 people that answered number 7. So I had just a limited amount of information. That doesn't mean I can take it back and say, okay, I would have 9 people that said 4. I don't know. We just don't have the information on it. So we don't try and extrapolate backwards. We're given what we're given, and we don't throw a fit. We get what we get, and we don't throw a fit. Okay? So that is everything for the chapter. I have here, and I had some yesterday. How much was, I know this would be about several of them. Chapter review. This is everything. If you can do everything in the chapter review, you are set for the chapter test on Friday. We will have all of tomorrow to work on it. We will have all of Thursday, which is e-learning, to work on it. You can always email me questions. On Thursday, I will get the answer key uploaded so that we can look at that and check all our answers, but I want us to try first.